Sultani, Assistant Professor at LJ Institute of Engineering and Technology. Today in multiple integrals, I will teach you new topic, that is change of order of integration. So let's start. So first of all, we will see what is change of order of integration. Sometimes evaluation of double integral becomes easier by changing the order of integration. To change the order of integration, first we draw the region of integration with the help of the given limits. Then we draw a vertical or horizontal strip as per the required order of integration. This change of order also changes the limits of integration. So how I will make you understand this with the help of example. So here we have this one example. Change the order of integration and evaluate integration from 0 to infinite, integration from x to infinite, e raised to minus y upon y dy dx. Here this limit, which is x to infinite, this is the limit of y, and this one limit, which is from 0 to infinite, this is the limit of x. So compulsory we have to find out the integration of this function with respect to y first, then after with respect to x. But as you can see, the integration of e raised to minus y upon y with respect to y is not possible. So we have to change the order of the integration, and then after we will evaluate this integration. So here is the solution. Here x varies from x equals to 0 to x equals to infinite, and y varies from y equals to x to y equals to infinite. This is the graph we have drawn with the help of the lines x equals to 0 to x equals to infinite and y equals to x to y equals to infinite. X equals to 0 line, that is nothing but y-axis. Then after x equals to infinite line, we cannot represent x equals to infinite line in the given graph. Then after y equals to x, that is a line passing through origin. And then after y equals to infinite, so we cannot represent y equals to infinite line in the given graph. So this is x equals to 0 line, this is y equals to x line, and as y tends to infinite and x tends to infinite, with the help of these four lines we will be having this region of integration. Now we have to change the order of integration. Now you can see that this limit, which is from 0 to infinite, this is the outer limit and this is the limit of x, and x to infinite, this is the inner limit and this is the limit of y. Now to change the order of integration, we require outer limit of y and inner limit of x. So first of all, we will write down the outer limit of y from this graph, and then after inner limit of x from this graph. Here the region of integration is this one. Okay, so to cover this region of integration with the help of limits of y, we will take y from 0 to infinite, and then after we will take this horizontal strip, and for that purpose we will take x from, here you can see this is y-axis, so x will vary from 0 to this line, and this line is y equals to x. So x will vary from 0 to y. So the final limits are y is from 0 to infinite and x is from 0 to y. After changing the order of integration, x varies from 0 to y and y varies from 0 to infinite. So this is the given integration, that is integration from 0 to infinite, integration from x to infinite, e raised to minus y upon y dy dx, and this is equals to Now this is the integration after changing the order of integration. Now this is integration from 0 to infinite, this is the limit of y. And integration from 0 to y, this is the limit of x, and this is the same function e raised to minus y by y. Now this is equals to integration from 0 to infinite, e raised to minus y by y is a constant, and integration from 0 to y dx dy. Now first of all we are going to integrate with respect to x, then after with respect to y, and this whole function is of y, so it will be constant. Now integration of 1 with respect to x, that is x, and its limit is from 0 to y, and this integration, which is integration from 0 to infinite, this function e raised to minus y over y dy will be as it is. Now for upper limit y, it will become y, and for lower limit 0, it will become 0. So this result will be y minus 0, which is y, and y will cancel out. So we have integration from 0 to infinite e raised to minus y dy. Now integration of e raised to x, answer is e raised to x, but integration of e raised to minus x, that is minus e raised to minus x. Now integration of e raised to minus y, that is minus e raised to minus y, and the limit is from 0 to infinite. Now we will put upper limit infinite and lower limit 0. So minus sign will be outside, e raised to minus infinite minus e raised to 0. So value of e raised to minus infinite is 0, because it will become 1 upon e raised to infinite, and e raised to infinite is infinite, and 1 upon infinite is 0. And value of e raised to 0, that is 1, so minus 1 into minus sign, so it will become plus 1. So this is the answer of this double integration. Now we will see second example related to this topic. Change the order of integration and evaluate integration from 0 to a, integration from y to a, x upon x square plus y square dx dy. Here the limit of x is from y to a and limit of y is from 0 to a. So here is the solution. Here x varies from x equals to y to x equals to a, and y varies from y equals to 0 to y equals to a. Now with the help of these lines we will draw the graph. First of all, x equals to y line, that is a line passing through origin. Then after x equals to a line, that is a line perpendicular to x axis and parallel to y axis, passing through this point a, and its coordinate will be a comma 0. Now if you will find out the intersection point of this line x equals to a and y equals to x, you will get a comma a point. Then after y equals to 0 line, that is nothing but x axis, and then after y equals to a line, that will be a line passing through this point perpendicular to y axis and parallel to x axis. So the region of integration bounded by the lines x equals to y, y equals to 0, x equals to a, and y equals to a, that is this triangle, right? This is the region of integration. Now here we have to change the order of integration. Here the inner limit is of x and the outer limit is of y. So we require outer limit of x and inner limit of y. Now first of all we will find out outer limit of x. So this is the line x equals to 0 and this is the line x equals to a. So this will be the outer limit, which is from x equals to 0 to x equals to a. Now for inner limit of y, we will draw a vertical strip, that is this one, and this strip will meet this line at this point, and this line is y equals to 0, and this strip will meet the line y equals to x at this point. So y will vary from 0 to x. So the outer limit is from x equals to 0 to x equals to a, and the inner limit is from y equals to 0 to y equals to x. after changing the order of integration, x varies from x equals to 0 to x equals to a, and y varies from y equals to 0 to y equals to x. Here this is the given integration, that is integration from 0 to a, integration from y to a, x upon x square plus y square dx dy, and this is equals to, now you can see that this is the inner limit. This is the inner limit of x and this is the outer limit of y. But here this is the inner limit, y vary from 0 to x, and this is the outer limit, x vary from 0 to a. So this is equals to integration from 0 to a, integration from 0 to x, x upon x square plus y square dy dx. Now first of all we will integrate this function with respect to y, keeping x constant. So this x and this x square is constant. Now to find out the integration of this function, we will apply the formula of integration of 1 upon x square plus a square dx, that is 1 upon a tan inverse x by a. So this is equals to, this integration will be as it is, integration from 0 to a, this x is constant. Now integration of 1 upon x square plus y square, that is 1 upon x into tan inverse y by x, and the limit is from 0 to x, and this dx will be as it is. Now this is equals to integration from 0 to a, this x and x will cancel out. Now for upper limit x, it will become tan inverse x by x, that is tan inverse 1. Then after minus sign, for lower limit 0, it will become tan inverse 0. Now the value of tan inverse 1 is pi by 4 and tan inverse 0 is 0. So pi by 4 minus 0, answer is pi by 4. And this integration, which is integration from 0 to a, dx will be as it is. Pi by 4 will be as it is, and integration of 1 with respect to x, that is x, and the limit is from 0 to a. Now for upper limit a, it will become a, and for lower limit 0, it will become 0. So this is equals to pi a by 4. So in today's lecture, we have seen actually what is change of order of integration, and we have gone through 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.